everyone, welcome to the channel. I am Ankit Mishra, currently pursuing my PhD from chemical engineering from IC Bangalore. And today we are diving into something super exciting, creating powerful 2D geometry in COMSOL multi-physics. So whether you are starting out or looking to sharpen your simulation skills, this tutorial will guide you through some of the most essential and versatile tools COMSOL has to offer. So including, let's say in last lecture I have already discussed about the mirror and this array operations. So today I am going to talk about mirror, boolean operation, partition operation, as well as how to scale a geometry, something like that. So these tools form the building blocks of your simulation geometry, and mastering them will unlock a whole new level of modern flexibility. So buckling up, let's go and get created all of these things over here, and let's try to understand how to use these kind of things. So obviously I have already discussed this. This is the user interface of the COMSOL multi-physics 6.0. So first I am going to create some kind of geometry, let's say circle, right? So circle, if I want to create the circle in 2D, so there will be a radius and they will ask for the triangle and the center of the circle. Let's say here I will give it 0 and 0. And radius I will be taking is 0.2, right? So once I will do this thing, I will go to build cell selected, right? So after that you can see we have created a circle over here, and after that I want to move this, right? So how to use this move operation? So if you click on move, you are supposed to input the object. So your input is this object is circle, and if you want to move the circle's center from 0, 0 to 0.5 and 0.5, let's say 0.5 and 0.5. So you can see once I do this, will select circle is got shifted along, the center of the circle will get shifted at a coordinate of 0.5 and 0.5. So this is how these operations can be used. After that again we will be moving to some next operation today. So before that I will be creating the geometry and this operation that we have done earlier. And today again let's say I'm going to create a circle having radius is let's say 0.2, okay, and the coordinate is 0.0. And after that we are moving towards the next this thing, how to scale any geometry over here. So if I'll go and click on the scale, if I'll click on the scale, and then you are supposed to input the object, which object you want to scale, right? So here this object is the circle that you want to scale, and sometimes you can keep the input object, right? So this one is your input object, and if I allow these things, then we keep the input object, and this is isotropic. Isotropic means it will get a scale along all the direction, right? And after that you are supposed to scale, you have to use a scale factor. So let's say if I want to use a scale factor is 4. So in circle there is the radius of circle, right? So the radius of circle will get a scale up. So if you have a radius 1 meter, then if you are putting a scale factor is 4, so radius will get multiplied with 1 into 4, that is 4 times, right? So you can see how these things look like. And after that also, after scaling, you want to switch the coordinate of the center. You can have this kind of flexibility over here. You can use the coordinate of the center, and you can also shift the circle. So but I am not going to do these things right now. So at this moment I will be only scaling, and the scaling will be done on the basis of the radius or the diameter. If I do these things, you can see that circle got scaled up, but again you can see the earlier circle that was there, that is the input object. This is also here. If I'll enable this thing, so you can see now this object got removed, okay. So this is how this scale of things work, okay. So sometimes you are creating a geometry, and then you want, let's say you want to create some kind of diffusion profile, right? But at the later period you want to increase the size of the object, right? So by using this scale factor you can do this kind of things, okay. I hope this is clear to all of you. Now after that I am going to, okay, so there is one more thing here. If I am going to anisotropic, so if you go to anisotropic, that then in scale factor they will ask you about the scaling coordinate along x and y direction, and also along the center of scaling. So definitely center of scaling will be there, that was there in isotropic also, but in anisotropic also this thing is there. But again here there is one more parameter that is there, that is along, because anisotropic means you symmetrically you are not scaling the object, right? So here if I put this one is 1 and 1, so I'll change these things. Let's say this is 1.5 and 1, then let's do these things, how these things will get look like. So here if I will enhance this thing, so earlier it was a circle, but now you can see that a scaling factor along x direction I have increased to 1.5. So if I would have put 1 only, let's say if I will put 1, so then definitely circle will be 1, right? But if I will put 1.5, which is more than 1, right? So along x direction it will get elongated, but y direction I have fixed is 1, right? So again if I will build it up, so you can see along x direction it got scaled up in one by a factor of 1.5. But again if I want to scale up along y direction also, and if I will put 1.5 also, no. What you can see here, along both x and y direction we are scaling. We are adding a scaling factor. We are using a scaling factor 1.5. That is same. So again, it will give you a circular geometry, and you can see here. This is how these things look like. Okay. But again, if I will do these things, let's say 2.5 or sorry 2.0. Okay. So again, y direction circle will get elongated, and along x direction this will be additive. But this will not be a circle now, because if you want to make an ellipse, so ellipse is the part of circle where major axis, circle is the part of ellipse where major and minor axis is same, right? But in ellipse, what happens? There will be a major axis, there will be a minor axis. So let's say if major axis is 2 and minor axis is 1.5. So now if I will build distance, you can see the circle is getting elongated along y direction, because y factor, y scaling factor I have put substituted is 2. And now if I want to scale the center of scaling also. So if I want to scale the center is, let's say 0.5. So now what will happen? The center will go and get shifted. Center will get shifted along the y direction. So if we do this thing, so you can see here the center got shifted from 0.5 here. Sorry, this thing 0.5. So center got shifted here along this direction. And if I will do minus 0.5, see what is happening. Okay, so if I do this thing, so it will get shifted along that direction. Okay, so a scaling factor is a very important parameter over here that you have seen here, and this is very important. Okay, so in this lecture I have described two important tools for mirror, move, and also a scaling factor, right? So this is how you can make a complex geometry. So with subsequent lecture we will be going to the toughest level of COMSOL modeling in 2D geometry. So that's all for today. This tutorial on tools in COMSOL. I hope this gives you a strong foundation for building a complex geometry in your own simulation. So if you found this lecture is very helpful, please do like, share, and subscribe for more tutorials on COMSOL and chemical engineering simulation. So you can drop your questions or suggestion in the comment box, and I will be happy to answer them. This is Mishra signing off. Thank you. See you in the next video.